today we're going to move past all that stuff you learned in geometry about angles. Not that we don't still use that, but we're going to extend that knowledge into looking at angles in a more circular fashion. Not just something that's in a triangle, but an angle that happens through rotation, kind of like when we did revolutions per minute kind of thing, looking at something spinning. Here we have an angle. We have some names for this, so there's a little bit of terminology today. This is always our initial side. It's like where you would lie your protractor, and we typically think of that initial side going horizontally like this one does. This is the terminal side of your angle, and to create that angle you start at the initial side and you're going this direction with your angle. You could even put it, sometimes you'll see a little arrow at the end of that to show that it continues that direction. The angle created by the initial and terminal side is called theta. We're going to deal with both positive angles. Positive angles are the ones that we're used to doing. This is what we've been doing. As it rotates, it actually goes counterclockwise. This is like what we were working on with the protractor or with your unit circle. Those are positive angle measurements. From the initial side, you're going counterclockwise. If you have a negative angle, that's going to occur if you start in that same spot, but instead you go clockwise. A clockwise rotation is actually a negative angle. The angles we're going to work with, we're going to put them in standard position so that we can compare them more easily. To say that an angle is in standard position, the vertex is going to be at the origin. Should make sense. But the initial side, we are always going to put on our x-axis. Well, this is what we've been dealing with. Here it is. This is the initial side, and then we're going to put the vertex right here at the origin, and then this is going to wrap around somewhere, and there's our angle. But when we start that initial side on the x-axis like that, we consider that in standard position. Let's look at an example. Here's a nice angle, a 100-degree angle. It's in standard position. Let's talk about some coterminal angles. To say an angle is coterminal with another is to say that it shares the terminal side. Remember, this is your terminal side. What I'm going to do is I'm going to create another angle that still has this exact same initial side and this exact same terminal side, but is not a 100-degree angle. Now that may seem weird. Let's go ahead and fill in the blanks here. Two angles with the same initial side and the same terminal side. How could we come up with an angle that looks different than that one? Well, it has to do with that rotation that I was mentioning. I could still start right here, and what I could do is I could take my terminal side and start moving it over here towards 100, but keep it on going and going and going and going, and make it all go all the way to 360 and keep on going and keep on going and keep on going and finally stop. And then draw the terminal side. That rotation is possible, and it's still a nice little angle there, but it's not a 100-degree angle anymore. By showing this little spiral in here, I've shown that it is a 360 plus the extra 100, which is a 460-degree angle. Just by showing the spiral in there to show that that terminal side is wrapping around. To make a negative coterminal angle, I still have to start at my x-axis, and I'm still going to have to end here, but I'm going to have to, instead of going counterclockwise, instead of going that direction, I'm actually going to back up and I'm going to go clockwise around this way. What do you think that angle measurement would be? Well, if I went backwards, I've got to call it negative. How many degrees negative did I go there? If you think about it, it's 360 all the way around. And if this much is 100, how much would this have to be? It would be a negative, because I went clockwise, 260 degrees. And there's different ways to come up with that. You could think of it like here's 180 and then this was another how much more kind of thing. However you want to come up with that measurement. Let's try it again, but let's practice doing that with radians. My initial side still going to be on the x-axis. My terminal side is still going to be right here at pi over 3. Now the angle that they've given me is the one that just goes right here. But I'm going to wrap around to get another angle that's still positive. I've got to continue going counterclockwise. I'm going to go all the way around and then back. But I have to show that I'm doing that with the little spiral to say I'm starting at the initial side. I'm going to go around, all the way around, around, and now I'm going to stop. How far did we go? Well, here's the kicker. If I have the original in radians, I have to answer this one in radians. I need to be consistent with that. Now, I know that this much is pi over 3. How much is the rest of this? Well, remember, all the way around is 2 pi. It looks like I've gone 2 pi plus another pi over 3. Now, what would that add up to? You got to maybe, you can maybe do that in your head, but you basically are getting a common denominator. 2 pi written in thirds is really 6 pi over 3. Plus another 1 pi over 3. That angle that I have marked right there is a 7 pi over 3 measurement. Let's try it again. This time we're going to do a negative. I have to start on the x-axis. I have to end in this same spot. But because I want a negative coterminal angle, I'm going to work backwards to get there. It's going to start at the initial side and it's going to wrap around clockwise until it hits right there. It's probably helpful that I already know that all the way around is a 6 pi over 3. If you think about it, this much is just a 1 pi over 3. This must be all the rest of it so that it would add up. If you want to subtract it and show the work, you can. If you can do it in your head, even better. I've got the 6 pi over 3 is all the way around. Subtract out the chunk that I do not have shaded. This, or not shaded, but the part that I don't have is this, which I know is pi over 3. If you subtract it, then you end up with 5 pi over 3 for an angle measurement. I'm sorry, but we went backwards. It's a negative 5 pi over 3. Why don't you try doing that? See if you can come up with a couple coterminal angles. Give me one that's positive and one that's negative. I gave you one example with radians. I gave you another example with degrees. Sketch it and then tell me what its angle would be. Go ahead and pause the video so you can take some time to do that on your own. All right, go ahead and pause the video again and check this out and see if you agree with all of my answers. See if you disagree, see my work and see if you can figure it out. Now let's go ahead and tie in what we were doing yesterday with the unit circle. We filled our unit circle in with all kinds of information yesterday. Let's look at what happens. In the day prior to that, we talked about how sometimes the sine and the cosine ended up being negative, and the tangent. Sometimes those were negative values. Let's talk about why that would happen and see if we can see any patterns with this. If you think about what's happening in quadrant 1, we are up here in this quadrant. Remember that, let's go ahead and jot this down, that when we were putting those values along those ordered pairs, that it was x comma y, but that was always the cosine of theta, sine of theta, is what we learned. The cosine is your x, the sine is your y. If you put this unit circle on your x and y axis like we did, and look at this as though it's broken up into quadrants, when you are in the first quadrant up here, think about your x value and your y value. Well, in the first quadrant, they're both positive, which means that in the first quadrant, both your cosine and your sine will be positive values. We'll come back and do tangent at the end. Let's go over here to the second quadrant. On this one, you're going left and then you're going up. Left is negative. That's your cosine. It should be negative, but your sines will always be positive. Cosine will be negative, sine will be positive. When you move down into the third quadrant, you're going left and down. Both your cosine and your sine will end up being negative. And when you're in the fourth quadrant over here, you're going right, so the cosine will be positive, but you're going down, the sine will be negative. Now there are definitely some patterns, but really that should kind of make sense to you for what we did yesterday. Let's talk about tangents. Now your tangent, and we may or may not have gotten a tangent yesterday. It depends on the year, on whether we get to that on the unit circle day, but I'm going to assume we got to it. And the tangent value is always the y over the x, or the sine over the cosine. If tangent of theta is equal to the sine over the cosine, well, we just have to look at those two sines, S-I-G-N, to decide if the tangent will end up positive or negative. In the first quadrant, I'm going to be putting a positive number on top of a positive number. That's going to end up positive. First quadrant, everything's positive. Now, when I move over to my second quadrant, I'm going to be putting a positive over a negative. That's going to end up giving me a negative value. In the third quadrant, they're both negative. When I put a negative on top of a negative, I'm going to end up with a positive. In the third quadrant, tangent is actually a positive value. And in the fourth quadrant, we'll be back to a negative. You always need to be sure that you're careful as you decide what the sine or cosine or tangent value is, that you also acknowledge what its sign will be, whether it should be positive or negative. Let's try one here. Find the 6 trig functions of an acute angle in standard position whose terminal side contains the point -5, 3. I have to find all 6 trig functions. I'm going to be looking for the sine of theta, the cosine of theta, and the tangent of theta. But I'm also looking for the reciprocal functions, cosecant of theta, secant theta, and cotangent theta. I need to see a picture of this deal. I'm going to put it here. And it says that it is in standard position. That means that it's going to start on the x-axis. But it says that the terminal side goes through the point -5, 3. Think about where that's going to fall. Now this is not on my unit circle because it's going way out beyond 1 unit. But it all works the same because it's all proportional. I'm still going to be going left 5, up 3. Here's a spot that the terminal side of my angle should go through. It's going to look like that. Okay. Now, I'm supposed to find all the trig functions for that particular angle. And that angle, if you recall from your unit circle, from yesterday when we did the unit circle, I don't know that this is one of those special angles. It would be nice if it was, but I don't necessarily know that it is. But what we're going to create is what we call a reference angle. And the reference angle is always formed by coming from the terminal side. And actually I might not be able to, okay, I can't do this. I'm going to go ahead and make that end, so it might make more sense. I'm going to make my little angle end right there at that point instead of extending it. What I'm going to do is go ahead and create an angle that's going to have all the same values, the sine values, the cosine values. And I create that angle by always dropping back at the tip of my terminal side back to the x-axis. recall that from the unit circle, we kept having the same numbers pop up all the time. It's very symmetrical is what that looks like. This angle right here is going to be the same as if I were to draw that over here in this quadrant. It's going to be symmetrical. I'm still over a certain amount as I would be over there, and up a certain amount as I would be over here. I create the same triangle, but I flip it over into a different quadrant. But all the side measurements would be the same. So all the ratios are going to be the same. The only thing that changes are the signs. Because I moved left, this side length is actually a negative 5 units, and I went up 3 units. To find all the trig ratios, remember from the other day, we can just do a quick little Pythagorean theorem, and we can find the length of the hypotenuse in this reference triangle. So b squared, let's see, 25 minus 9 is going to get me, oh, sorry, my bad. I was hoping this was going to be a nice one. It's not a nice one. But I thought it was going to be that 3, 4, 5 triangle. But the 5 is actually one of my sides, one of my legs. And I'm looking for the hypotenuse. So that's going to be a 9 plus 25. That's 34. It looks like my hypotenuse is going to be the square root of 34. Now that I know all 3 sides, I can sit here and find all those trig ratios. The sine, and I'm always remember that your vertex of your angle has to always be down here at the origin. So I'm talking about theta being down there at the corner, and then your sine value would be opposite over hypotenuse, 3 over square root of 34. Rationalize that, it's going to end up being 3 root 34 over 34. The cosine is going to be the adjacent over the hypotenuse. And again, I'm going to have to rationalize. It's going to end up being a negative 5 root 34 over 34. And tangent is going to be opposite over adjacent, negative 3/5. And then we just go through and we flip all of those to do the reciprocals. Root 34 over 3, negative root 34 over 5, and the cotangent would be a negative 5/3. Those reciprocal functions keep the same signs as their regular function does. All right, so let's recap on that one. This is a pretty common type of problem that you'll see on your homework. You have to plot the point. That's where we started. Plot the point. Draw in the terminal side, and always drop back to the x-axis. If your terminal point was over here, let's say, then I would draw the terminal side and drop back to the x-axis, and up here, after I drew that triangle, let me go ahead and do that in a different color since we're done with this problem. If your terminal, or if your point was down here, I would draw, it still has to start here, it's going to come down to there, and then I drop back to the x-axis. See how that's the right angle? That's not going to be my theta. My theta is always up here at the vertex. And then you have this little triangle that you would have your opposite, adjacent, hypotenuse stuff to work with. Once you have drawn your little right triangle and have theta up here at the vertex, then you just kind of work through what we had done the other day. All right, here's our last thing. This says find the trig function of the given angle. Think about whether it's positive or negative. We're going basically to your unit circle, but here's the deal. No cheating. No looking at your unit circle. That's too easy. It will never come easily to you until you force yourself to start thinking about, you have to think about it in your head. You can't always just go look at your unit circle. There's several problems here. I'm going to get you started on this thinking process, and then you finish out. First of all, the sine of a 315 degree angle. All right, I'm going to clutter this up. I don't know, you may have to do this on a separate sheet, but of course the idea is that you eventually can do this without drawing it. That's ultimately what we're hoping for. If you look at this one, 315 degrees, you have to know where that's at. That's why I was kind of training you early on. Know your angle measurements. 300s are down in the fourth quadrant. It ends in a 5. It's got to be one of the 45s. It's down here. So thinking about that angle right there, the sine, remember that the sine on all the 45s was a root 2 over 2. I know that this is going to be a root 2 over 2. But we have to decide, will your sine value be positive or negative? Sine is the y. It's down. It's going to be a negative root 2 over 2. Let's try another one. Tangent of 5 pi over 3. All right, we just did it yesterday, but let's think through this, because I know you probably don't have this memorized. Where would 5 pi over 3 fall? Well, just start counting, and I usually converted those to 6, so think of that as 10 pi over 6, and let's start counting our way around. Here's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Okay, sorry, backtrack. I might have counted by 45 here. Here's 0, okay. You're counting the 30s. Remember, the 6 are the 30s. So you skip over your 45. Here's 1, 6, 2, 6, 3, 6. 4, 6, 5, 6, 6, 6. And really, once you get good at this, you just jump to 6, 6. I know that's 6, 6. But I'm looking for 10, 6. So here's 7, 6, 8, 6, 9, 6, 10, 6. It's this first one right here. All right. Think about what your tangent is at that spot. Tangent is your sine over your cosine. If you need to write that out, you can. But ideally, we're going to get to the point where we can figure out, all right, so I'm over a little and down a lot at that spot. So the short leg is here, my long leg is here. You can do your opposite and adjacent, but in the end, I know that when my tangent is far away, like these tall ones, that my tangent was just root 3. I always remember that because it was, remember, if it's over 3, it's a root 3. But we have to work on what we're really practicing on here is figuring out what the sine would be. Remember for tangent that it's the sine over the cosine, so it depends on those sines, S-I-G-N. Right here, I'm right and I'm down. That's a positive and a negative. That would make my tangent value negative. All right, now my goal here is to teach you the thought process. I might be slowing you down. You can maybe do this faster without me explaining it, but I got to go through this with you so you can get to the point of doing it by yourself. Let's try number 7 together. I'm coming down here. Now this one's a negative angle. That's a little bit tricky. 7 pi over 6. Well, I could count it, bump, 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 but remember, here's 6, 6. So 7, 6 is just one more. It's right here. But the kicker is that it's a negative. Rather than going this way, I have to back up that much. So I'm going to back up to 6, 6, and 7, 6, negative 7, 6 is actually this first one right here. Let's draw that in. We're looking for cosine. Cosine is your x value. If you look at that, that's going to be your long leg right there. That's your long leg. That's going to be your root 3 over 2. But we're going negative, so it's a negative root 3 over 2. All right, I'm going to do one more and then you're on your own. 5 pi over 6. Here we go. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Oh, that's the same spot as that last one was. Exact same spot, isn't it? It's just that it happened to be a positive angle. A positive 5 pi over 6 is the same as a negative 7 pi over 6. They land in the same spot. Those are called coterminal angles. But this time I want the sine value. The sine is my y value. That's how far up I'm going. That's going to be my short leg. If it's your short leg, that's going to be a 1/2. And since it's a y value, you're going up. I think it's a positive 1/2. Okay, I did 4. You have to do 6. Go ahead and pause the video. Force yourself to think through those. No cheating. And come back to me when you've got them all done. Let's see how you did. I want you to give it a glance and check all of your answers, and then I'll go briefly over each one. If you're good, then you're good, and you can keep on moving. All right. Now, I had to spread this out, so here's my number 9. Looking at number 9, it's a negative 120-degree angle, which kind of is more downward here. I drew in the reference triangle to help you see this. I'm looking for the cosine. So I'm over a little bit. That's my short leg. That would be 1/2, but since I'm going left, it's negative. I'm just going to go down the list here. Here's number 11. It's a negative angle, so I have to wrap backwards around. 270 takes me back to here. Don't overthink this. Don't have to worry about a reference triangle. It's just straight up, and the sine value there ends up being 1. On number 13 here, oh, I did not draw that angle right. Let me look at that again. Here's how this worked. This was a weird one, 11 pi over 2. Where's that? Well, I don't know. Here's 1 pi over 2. This is 2 pi over 2, 3 pi over 2, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi over 2 is where that ends up being. All of those were over 2. All right, so I'm way down here. I don't know how many times I wrapped around. What was that? There was 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves. Oop, it went crazy there. 10 halves, 11 halves. That's how you would draw that triangle or that angle, is you'd have to show that spiral that many times around. Either way, it ends up in that same place straight down. We're looking for the secant. I don't know the secants, but I know the cosine there would be 0 because I'm not moving left and right. My x value is 0. The reciprocal of 0 is undefined. Let's come over here, number 10. This one is a 225-degree angle. 200s are down here. It ends in a 5, so I know it's one of my 45s. That makes this a 45, 45, 90 triangle. The legs are the same. They're both root 2 over 2. I'm looking for the tangent, though. Remember that if the legs are the same, then your opposite and adjacent are the same thing, and you end up with a 1. Recall that because you're left and down, you'd have a negative over a negative, which makes your tangent positive. Here's 3 pi. It also was one of those that wrapped around. Here's 1 pi, 2 pi, 3 pi. It ends up straight across horizontal. I'm looking for the tangent value. The tangent of anything on the x-axis is always 0. Last one, 2 pi over 3 is one off of our unit circle. It's just right here. This first one passed the y-axis. Here's your short leg, and here's your long leg. Well, cosecant, I don't know, but I do know sine. Sine is my y value. I'm up a lot here. That's my long leg. That's the root 3 over 2. But I need the reciprocal. So here's my root 3 over 2. These are arrows. It's hard to see that, but I flipped it. It's a 2 over root 3. And then I rationalized, final answer, 2 root 3 over 3. And I should note here that since you're up, your y value here is positive, so your cosecant is going to be positive. All right. Hope that made sense. I want you to do some practice on your unit circle doing things like that where you have to think through all that different stuff of where it's at and what that's going to do to it. Now, if I start giving you things like this, the 3 pi or the 11 pi over 2 that wrap around a bunch of times, okay, it's okay to draw that stuff out to get a feel for it, but if you can start getting familiar with where your angles and radians are and visualize that triangle with that short leg and long leg, I think you're going to be better off the sooner that starts to click for you. Come see me if you're struggling with that. Let's practice it. Let's get it figured out. Good luck.